Welcome to Lesson 10, the final lesson in our Classifying Matter series. In this lesson, you will learn to differentiate between elements, compounds, and mixtures, determine if a mixture is homogeneous or heterogeneous, and determine how to separate different types of mixtures. Make sure you're taking good notes. Let's get started. So, back to how we classify matter using this flowchart. Today we're going to focus on mixtures. So we know that mixtures can be physically separated because the components of a mixture are not bonded together. There are two types of mixtures. There's a homogeneous mixture, also known as a solution, that has a uniform composition. There's also a heterogeneous mixture, which does not have an even or uniform composition. So, as you can recall, when we looked at pure substances, their particle diagrams, every particle was identical. But here, when we look to the right and we examine mixtures, we can see that the particles within are not identical. So in the first mixture, we have the diatomic red particle of oxygen, and we have the diatomic white particle of hydrogen. But the red particles and the white particles are not the same. So now we know we have a mixture. In the diagram to the very right of a mixture, what we can see is that we have water molecules. They kind of look like Mickey Mouses with white ears and a red face. So we have water molecules, and then we have a monoatomic red atom as well. So again, there are two different types of particles in this mixture. In a pure substance, each particle will have exactly the same composition, and in a mixture, each particle could have a different composition. So mixtures always involve two or more different substances. Remember, the word substances implies either an element or a compound, and they're going to be physically combined, meaning they're not bonded together. You can always have a varying percentage or composition within a mixture. So here you can see we're making salt water, but you can have salt water with a small amount of salt in it, and we'll call it salt water, or you could have very salty water with a lot of salt in it, and we'll also call it salt water. So mixture composition can vary. And each substance in a mixture maintains its own properties. So when you make salt water, the salt still tastes salty and the water is still wet. Remember, in a mixture, we can have elements, we could have compounds, or a combination thereof that are not bonded together, and so they're not going to be in a fixed proportion. So here we have a mixture that includes a compound of the red and blue particle and an element of just the red particle. So when we think about how mixtures can vary, I automatically think about food. So first you can see one of my favorite soups. It's a Thai soup called Tom Kha. And so this Thai soup is delicious, but in some restaurants you might get it and it'll be a little bit spicy. And another restaurant you might get it might be very spicy. So the composition or the amount of spice in the soup can change. Also, you can see here we have a bunch of chocolate chip cookies. Now, these are all called chocolate chip cookies because they are mixtures of the same things, butter and sugar and chocolate chips, but the amount of chocolate chips and the butter and the sugar can vary from recipe to recipe, thus making each cookie have slightly different attributes. So there are two major types of mixtures. There are homogeneous mixtures, which are also known as solutions. In a homogeneous mixture, the particles are uniformly or evenly mixed together so that on a macroscopic level, you can't tell the difference between one scoop of the mixture and the next. An example of a homogeneous mixture would be salt water. Whenever you see a chemical compound formula that's preceded with the AQ in parentheses, it means aqueous or dissolved in water. All aqueous substances are mixtures. If you think about salt water, if the salt is thoroughly mixed within the water, if you were drinking it, the first sip, the third sip, and the last sip of the salt water should all taste identical, and you won't be able to pick out the salt from the water. Here are some more examples of homogeneous mixtures. So when we have these sports drinks like Kool-Aid, when it's completely dissolved, so that's one of the keywords that you'll see in a homogeneous mixture is, so when it's completely dissolved, then we have a homogeneous mixture. Perfume is another example of a homogeneous mixture. You want to have all of those aromatic compounds evenly mixed throughout your bottle. Not all homogeneous mixtures have to be a substance that's dissolved in a liquid like water. Here we have a brass trumpet. Brass is a homogeneous mixture of two solid metals, copper and zinc. Heterogeneous mixtures are mixtures that are not evenly or uniformly mixed, so they have distinguishable parts. So oil and water has a distinguishable oil layer and a water layer. Or when we look at this fully loaded pizza slice, we can distinguish, we can pick off the mushrooms if those are not your favorite, or you can pick off the olives. But we can see that there are sections of the pizza that have different parts. It's important that you're able to distinguish a compound formula from a mixture formula. So compound formulas are going to have the compound formula followed by the state of matter, which could be an S for solid, an L for liquid, or a G for gas. Now, a mixture formula is going to have the same compound formula, but it's going to be followed by an AQ for aqueous or dissolved in water. So whenever we see AQ, we know that we have a homogeneous mixture in water. Summary, if you have a single capital letter in a formula, it's an element. If you have two or more combined symbols or capital letters, you have a compound. We know that all elements and compounds are homogeneous, meaning they're uniform throughout because they only have one particle type. They're pure substances. If no chemical formula can be given or found, then we know that we don't have a fixed ratio of components, and therefore you could have a mixture. Now, the mixture could be homogeneous or heterogeneous. So by now, you should be able to determine if a mixture is homogeneous or heterogeneous. Separating mixtures can be done based on physical properties. Since the components of a mixture are not bonded, each component maintains its individual properties. So we're going to look at several separation techniques. Some of them can involve boiling point and freezing point, density, particle size, solubility, and magnetism. So the first example we're going to look at is called filtration. Filtration separates particles based on their particle size. You can only use filtration if you're trying to separate a solid from a liquid. You cannot filter things that are completely dissolved. Distillation is a process where we can separate components of a mixture by boiling them. When we distill something, what you can see is we start on the left by boiling a liquid until it becomes a vapor. The vapor then rises and travels through the tube. As the vapor travels through the tube, the vapor cools and it recondenses to form a liquid. While we're doing this, we make sure we watch the boiling point so that we collect only the vapor at its boiling point to make sure it's really pure. Distillation is one of the processes used to purify ethyl alcohol. So when we distill, you must have 2 or more liquids with different boiling points. Another way to separate a mixture when we have a homogeneous mixture of a substance that is a solid completely dissolved in water is evaporation. So again, you can never filter a substance that is a solution or completely dissolved, but you can evaporate. Chromatography is a technique that you likely used in living environment. You used it to find the nearest relative to a theoretical cancer-curing plant called Botanicurus. Chromatography uses polarity and particle size to separate different components. The prefix chroma means color, so we separate components that are different colors based on the fact that not only are their colors different, but so are their polarity or their ability to dissolve in a liquid. So when we look at the animation to the right, you can see that the blue ink is not very soluble, so it doesn't travel very far, while the yellow ink has a more similar polarity to the liquid, so it travels further. So if a student wanted to separate a sample of a solution, remember a solution tells us the kind of mixture, of sugar water, what method should she use? Remember, you can never filter a solution or an aqueous substance. So here we would have to use evaporation. So by now you should be able to determine which technique would be best to separate different mixtures. You've now reached the end of lesson 10. You should be able to differentiate between elements, compounds, and mixtures, determine if a mixture is homogeneous or heterogeneous, and determine how to separate different types of mixtures. That concludes lesson number 10, Mixtures and Separation. Make sure you've taken good notes. Write down any questions you have and bring them to class. We will discuss them. Complete your homework on Google Classroom, and don't forget, put your Regents Chemistry reference table and non-graphing calculator back in your backpack so you are prepared for class. I'll see you soon.